Okay, I should be live now. I forgot to update the category name thing. Let it work actually. It does, even if you don't set anything. And I should be able to just use one of the lower qualities so I don't lag out my own stream. But yeah, let's just update. Where's the update stream info? Here. So we're gonna do, let's just set the category first. So that is software and game dev. Now this is not technically development, this is study. So let's just do co-working and studying, I guess. But this is technically software related, so programming. That's the tag I'm looking for, yeah. And after that, maybe a country tag, because that's where I'm from. That's actually gonna help like with discovery and everything, but stream language is still gonna be English. That's something I'm not gonna change, and I do not have any of these. And this is not a read-on, this is not branded content. Okay, that can stay. And as for the title, we can go with learning the C, because that's essentially what I'm doing right now. I'm gonna read the C programming language book. I have a GitHub repository set up for that, and we'll continue following there. Default notification is fine because no one's getting notified anyways. One thing I do need to test is chat notifications and alerts, because otherwise I wouldn't know if anyone's actually sending messages or not yet, at least. There's probably, I should have like a second device that lets me monitor chat at least. Yeah, I'm gonna do that. In the meantime, you can look at CMatrix. I can actually hear music. I don't know if I should let the stream hear that as well, because it's gonna be the same music on loop all the time, and I'm not so sure about that. And I have zero noise suppression, so deal with it. Stream quality and everything is good, so I'm gonna leave it at that. Okay, I have the chat open. Okay, oops. I need to, okay, enable filtering, we'll turn that off. And what else? And everything else can stay the same. I'll just stop this preview because I don't want to bog down my bandwidth. And it's pretty quick as well. So if I alt tab, it's like 5 seconds delay from my own room. That's a bit odd, but hey, that's what I got to deal with. So today's topic, I have Google open because the music, I don't want to link show the page, but that's fine. We'll start off by, I have like already some existing code and other stuff that I was playing with, but the main focus is the C programming language, okay? And that basically lives over here, which is on my page. If you go the C programming language, I skipped a day. this PDF and everything. So let's just open that. What do you call it? It's some documents. I should go to the repo one code. So we have the C programming language and the PDF. Now I'm gonna open with, I really want to use Chrome for this. Yeah, let's just go with Chrome, because that way I'll have like a different browser for, what do you call it, a research, and then we'll have one for actual, I don't know what I'm getting at, but you get the idea. We'll have it like this. So we have code in the middle, browsing on the right, and then the stream at the very end. I'm going to use this, yeah. And we'll have the sidebar on with the fit to be like that. So the stream can read it. Maybe a bit wider. Yeah, I don't really like the flashbang. If there's like a dark mode PDF reader, can you force dark mode on Chrome? I don't think you can. One sec. Why wouldn't you just make that the default? But now that this works, if we install the I don't know if this extension has access to like the PDFs or not, but if it does, I'm gonna be really happy. No, this is a protected page. PDF dark mode. All right. That doesn't work. How does it work then? I have to go to the Chrome extension details and check the box. Okay, never mind. It does make sense that otherwise it won't work, because this is a system file and I don't think browsers like directly have access to you for them. Well, that's a bummer. We'll figure it out tomorrow then. Today we deal with the, what do you call it? We deal with the scuff. So this is supposed to be my browser, right? I'll go with this. It switches automatically, I don't like that. New window. And I'll do this. Code, C programming. Let's just pin this for now. All right. Yeah, that's more like it. Where's the preface? Let's zoom in a little more. Okay. All right, cool. Wait, is this already using an extension? No, it's not. This is just the built-in reader. I don't like that zoom. It's off center now. Okay. So if I go 150, okay, I should be able to do this. Yeah, this is perfect. I'm gonna get rid of that. We have this. We have the browser. Everything's in place. This is perfect. So let me just make sure on the phone that everything's readable. Text. I'm waiting for it to show up. Okay. On phone, if you're on like the vertical rotation, this is not readable. But if you go landscape, that is very much readable. Yeah. And I'm like hoping for desktop readability. So if it's readable on phone, I can assume that okay, on a desktop it should be readable as well. Let me just put it on charge. Okay. And what about the C matrix? Does this stuff like even load? Yeah, bitrate's probably dying, but it works. And what about GitHub? That's the one thing I'm worried about. It's readable. Yeah, sure. All right, so get to studying. I'm gonna pretty much read line by line and work on the code. The thing is, I've kind of cheated already, and if I go, let's just do, yeah, C programming. I'll see, I have the files already here, and then if I do, yeah, so this is already, like, I'm in the 1 point, I don't know, 1 or 2, somewhere around there, but I'm gonna like start over. So this is just like boilerplate code. I'm gonna remove everything and then just have it there. Yeah, this is the minimal C program technically. And we have, so this is the run file. I have a formatter that runs using the Microsoft style because I like having the angle brackets on the new lines on all of them, and Clang to just format them. And as for the compile flags, since what do you call it? I'm using the C89 because that's the ANSI C standard that this was written in back at the time. And I'm having like warnings on, even though this doesn't really play well with the book, because everything the book does is kind of outdated right now. So such as if I go to main C, it doesn't have a return type, like the int. It doesn't have the actual explicit return 0 and doesn't even have a void. So I need to do all of this outside the book's instructions to get it to like be compliant, but I'm just not going to do that. So yeah, this is like our state. I'm going to just do a commit, which is okay. And that should be it, and we can start programming. To read the preface, let's just go. The computer world has undergone a revolution since the publication of the C programming language in 1978. Big computers are much bigger. The personal computers have capabilities that rival mainframes of a decade ago. During this time, C has changed too, although only modestly, and it has spread far beyond its origins as the language of the Unix operating system. The growing popularity of C changes in the language over the years, and the creation of compilers by groups not involved in its design combined to demonstrate a need for a more precise and more contemporary definition of the language than the first edition of this book provided. Sorry, my bad. I was like missing the tone because there's also like music playing in the background. I'm gonna try to get rid of the music at one point, but I'm just like too anxious right now, so I'm gonna keep it. In 1983, the American National Standards Institute, or ANSI, established a committee whose goal was to produce an unambiguous and machine-independent definition of the language C, while still retaining its spirit. The result is the ANSI standard for C. The standard formalizes constructions that were hinted but not described in the first edition. I really am curious about reading the first edition, like how was C pre-standardization? Particularly structure, assignment, and enumerations. It provides a new form of function declaration that permits cross-checking of definitions with use. It specifies a standard library with an extensive set of functions for performing input and output, memory management, string manipulation, and similar tasks. It makes precise the behavior of features that were not spelled out in the original definition, and at the same time states explicitly which aspects of the language remain machine-dependent. The second edition of the C programming language describes C as defined by the ANSI standard. Although we have noted the places where the language has evolved, we have chosen to write exclusively in the new form. For the most part, this makes no significant difference. The most visible change is the new form of function declaration and definition. Modern compilers already support most features of the standard. We have tried to retain the brevity of the first edition. C is not a big language, and it is not well served by a big book. We have improved the exposition in critical features, such as pointers and that are central to C programming. We have refined the original examples and have added new examples in several chapters. For instance, the treatment of complicated declarations is augmented by programs that convert declarations into words and vice versa. As before, all examples have been tested directly from the text, which is in machine-readable form. Appendix A, the reference manual, is not the standard, but our attempt to convey the essentials of the standard in a smaller space. It is meant for easy comprehension by programmers, but not as definition for compiler writers. That role properly belongs to the standard itself. Appendix B is a summary of the facilities of the standard library. It too is meant for reference by programmers, not implementers. Appendix C is a concise summary of the changes from original version. Okay, so I get to see the actual diff. As we said in the preface to the first edition, C wears well as one's experience with it grows. With a decade more experience, we'll still feel that way. We hope that this book will help you learn C and use it well. Okay. Yeah, big thanks to friends. Sure, I'm not going to read names right now. In preface to first edition, I'm not going to read it either because that's kind of redundant. Now, one thing I realized, I'm not showing my cursor when I'm recording this. So the problem is you guys don't know like which line I'm referring to. So I'll always have to use highlighting for that. But I'll keep mostly what I'm reading up top so you can like follow along. So if I'm reading the paragraph, like the first paragraph, I'll keep it there. But I'm reading the second one, I'll move it up like this and then like that. You can continue like this, yeah. Chapter 1, Tutorial Introduction. Let us begin with a quick introduction in C. Our aim is to show the essential elements of the language in real programs, but without getting bogged down in details, rules, and expectations. At this point, we're not trying to be complete or even precise, save that the examples are meant to be correct. We want to get you as quickly as possible to the point where you can write useful programs, and to do that, we have to concentrate on the basics. Variables and constants, arithmetic, control flow, functions, and the rudiments of input and output. We are intentionally leaving out this chapter features of C that are important for writing bigger programs. These include pointers, structures, most of C's rich set of operators, several control flow statements, and the standard library. This approach and its drawbacks. Most notable is that the complete story of any particular feature is not found here, and the tutorial, by being brief, may also be misleading. And because of the examples do not use the full power of C, they are not as concise and elegant as they might be. We have tried to minimize these efforts, but be warned, another drawback is that later chapters will unnecessarily repeat some of this chapter. We hope that the repetition will help you more than it annoys. I forgot my own rule. I kept reading without scrolling. In any case, experienced programmers should be able to extrapolate from the material in this chapter to their own programming needs. Beginners should supplement it by writing small programs of their own. Both groups can use it as a framework on which to hang the more detailed descriptions, that being in chapter 2. Okay. Getting started. The only way to learn a programming language is by writing programs in it. The first program to write is the same for all languages, prints the words hello world. This is a big hurdle. To leap over it, you have to be able to create a program, text somewhere, compile it successfully, load it, run it, and find out where your output went. With these mechanical details mastered, everything else is comparatively easy. That is true. In the C program, to print hello world is, include stdio.h, main, and then printf hello world. So let's just run that. So we have include stdio, we have main, and then we just need to do printf hello world. All right, that's our first program right there. And if we now do just how to run this program depends on systems you're using. As a specific example, on the Unix operating system, you must create the program in a file whose name ends in .c, such as hello.c, then compile it with the command cc hello. Okay, now one thing I'm gonna try is, where is this? This is probably like alias to Clang again. Yeah, every compiler is like GCC. This is also Clang. And that is also Clang, so it makes sense. So if I want to run it, I'm gonna do, if you haven't botched anything with such as omitting a character or misspelling something, the compilation would proceed silently and make an executable file called a.out. If you run a.out by typing the command, it will print hello world. Okay, let's just try that. We already have the run script, so, oops. Yeah, so the run script will already do the formatting. That's an extra step, but other than that, it will take Clang. It will put the output in main, call it call it just main, and then after running it, we'll remove the file and the debug symbols that were generated by the compiler flags. That should be all. So we do run, and we have it. So that's hello world. Now the issue is every time we run this, we're gonna have these 3 warnings that are generated constantly, and that is technically noise, but we have to deal with it. Not much else we can do. All right. Okay, a small break. I'm gonna get some water. Okay, so now for some explanations about the program itself. A C program, whatever its size, consists of functions and variables. A function contains statements that specify the computing operations to be done, and variables store values used during the computation. C functions are like the subordinates and functions in Fortran, or the procedures and functions in Pascal. I don't know either of them. Our example is a function named main. Normally, you are at liberty to give functions whatever name you like, but main is special. Your program begins executing at the beginning of main. This means that every program must have a main somewhere. Main will usually call other functions to help perform its job, some that you wrote and others from libraries that are provided for you. The first line of the program, include stdio.h, tells the compiler to include information about the standard input-output library. The line appears at the beginning of many C source files. The standard library is described in Chapter 7 and Appendix B. Okay. One method of communicating data between functions is for the calling function to provide a list of values called arguments to the function it calls. The parentheses after the function name The parentheses after the function name surround the argument list. In this example, main is defined to be a function that expects no arguments, which is indicated by the empty list. Now that, as far as I know, is technically wrong. An empty list without void means it takes any number of arguments. So that's something they change later down the line, I think. So the full program basically looks include stdio.h, which is include information about the standard library. Then main with parentheses define a function called main that receives no argument values. Statements of main are okay. Then opening curly brace, statements of main that are enclosed in braces, and then the printf. So main calls library function printf to print this sequence of characters, and then \n represents the new line character, because otherwise it would just print the same output and have my shell on the same line. But modern shells can handle that. So if we just we leave out the \n part, right, and we do run. You see my prompt will still come up in a new line, but this character broken, I don't know what this is, but that basically means the output did not have a new line. I'm not going to do that. I'm gonna, let's still have that. All right. Also, that basically is our first C program. Yeah, that's the figure number. The statements of a function are enclosed in braces. The function main contains only one statement, which is printf hello world. A function is called by naming it, followed by a parenthesis list of arguments. So this calls the function printf the arguments hello world. Printf is a library function that prints output. In this case, the string characters between quotes. A sequence of characters in double quotes like hello world is called a character string or string constant. For the moment, our only use of the character strings will be as arguments for printf and other functions. The sequence \n in the string is C notation for a new line character, which when printed advances the output to the first left margin of the next line. If you leave out the \n, a worthwhile experiment, you will find that there is no new line at the advanced after the output is printed. Yeah, so that's the broken pipe character we saw. You must use \n to include a new line character to the printf argument. If you try something so that's not what they meant. They meant just having a, what do you call it? Just trying to add a new line like this. Yeah, that is broken, not the correct syntax. The C compiler will produce an error message. Let's actually see the error message. So it says expected error, missing terminating character because of the, missing quotation, and then the missing semicolon, and then the missing parenthesis. Okay, a lot of things basically. So let's not do that. And then we have a \n character end. And now this is the part about and \n. So printf never supplies a new line character automatically, so several calls may be used to build up an output line in stages. Our first program could just as well have been written like this. So if we do let's just commit this. Let's just call it first program. And then to do first program without \n. So that would be, we do hello. Oops. And then something like that, right? So hello world and a new line to produce identical output. So let's just try that. Yep. Notice that \n represents only a single character. An escape sequence like \n provides a general and extensible mechanism for representing hard to type or invisible characters. Among the others that C provides are \t for tab, B for backspace, \quotes for double quotes, and \/ for the / itself. That is, there's a complete list over at section 2.3. Okay. So now on to the exercises. What's the, okay, you should commit thanks. So now that we have our C program committed, we can do the exercises. We'll do the exercises in the main file itself, and then just like commit it with the title that it was an exercise. So one thing I'm gonna do, what is NC? It's a command. So let me see. Yeah. So I'll just do so NIC is inbound right now. Yeah, so this makes it much easier for me to type. All right. So run the hello world program on your system, experiment leaving out parts of the program to see what error messages you get. So we'll just revert back to, yeah. Oops. So we have our output and we're just gonna do, this is as 1.1, was it? Yeah. Something like that should be okay. The next exercise is experiment to find out what happens when prints, it should be printf. Yeah, printf's argument string contains \c, where C is some character not listed above. So it wants me to use illegal escape characters, basically. If we do that, so let's just do hello world / I don't know, 8. And that's definitely not a legal character, so that's a warning, and it just prints the character itself. Interesting. So unknown escape sequence, it will just print the character itself without actually doing anything. Interesting. Is that the expected behavior? Yeah, I'll just type it unknown escape sequence. So we're at 1.2. Maybe we should like stop and have like every day be a new section, but that way we'll have problems with chapters like these. So maybe a time window makes more sense. Yeah, let's just do like half an hour. That sounds nice though. Half an hour every day. Yeah, I'll continue. I got energy. So 1.2, variables and arithmetic expressions. The next program uses the formula, Celsius E. Yeah, Celsius is 5 times 5 by 9 times Fahrenheit's -32. I don't know how to like spell out math expressions. To print the following table of Fahrenheit temperatures and their centigrade or Celsius equivalents. So we'll have an output like this. The program itself still consists of the definition of a single function named main. It is no longer than the one printed. No, it is longer than the one that printed hello world, but not complicated. It introduces several new ideas, including comments, declarations, variables, arithmetic expressions, loops, and formatted output. So if I were to just like type it out, identical to this, we'd have, this is gonna be tough. Yeah, let's not do that. We can have it like side by side. It makes sense for like this instance at least. Oopsies. Why did it go back? Wait, can I not go forward on an open file? 1 second. That's 150. This is a bit annoying. Where was it? I gotta ask the program. So if I were to just copy line by line, I think they did it like this because C89 had the restriction of having all the variables like declared at the top of the function, or like you cannot use it inside the loop itself. Yeah, something like that. And then we have int lower step, and then we have I should like explain line by line what we're doing pretty much. Yeah, let's undo that. So declaring our two variables, which will basically be used as the outputs for what the current Fahrenheit and Celsius is, I'm assuming. Yeah, that is what they're using for. We know our Fahrenheit list because we're going to iterate over this Fahrenheit and print the actual Celsius values. I'm pretty sure because the formula was like, yeah, for a given known Fahrenheit, what's the Celsius? Okay, so this is a Fahrenheit to Celsius table. We should add comments as well. Yeah, that sounds good. So if I do, okay, then what we're basically doing is using the bounds for looping. So where do we start, where do we end, and how much do we iterate? Because we can't just print from 0 to 300, that would be stupid. I mean, it wouldn't be stupid if you needed, but you get the gist. So we start by we start at our like base, our initial number, then while our Fahrenheit is less than or equal to upper, so we're basically looping every time we're still at our within our bounds, and then we basically increment every time we do a step. So that's this is a bit dumb, whatever. So we do fine. So we increment, this will complete our loop and still doesn't print anything. Or why is it uninitialized? Oh, I never ran these lines. Lower is 0, upper is 320. So these basically we start from 0, we go up to 300, and every time we increment by 20. That's the idea essentially. All right. So now within this we do, well, this is where our formula comes in basically. So our Celsius is 5. Now there's a reason they're making me do not this, which is 5 times 9. Like that's the actual formula, if you look at it. But if I do it like this, I would end up truncating and end up with like a 0. So the book isn't telling me exactly why they're doing the formula like this, but that's the whole idea behind it. So if we do a multiplication instead with the rest of the term, this will basically produce, what do you call it? First we multiply and then we divide, but basically that's the idea. So in the order of operations, this would be it. But the book hasn't told us yet that. So we'll just delete that. Then we need to print it. So, and this is where format strings come in. I don't think the book has told us that either, but %d, and wait, there's supposed to be a new line here. So a digit, a tab, and then another digit, and then a new line. But why are you complaining on this? Okay, so this should be our complete program. If we try to now run this, we have our table which starts at 0 and goes all the way up to 300, with starting being -17 and 148. That's where we end. So if we look, oh, we start at 1. Interesting. Is the output of the book wrong? because like only the first line doesn't match, but everything else pretty much does. So I'm pretty sure like they started with lower 1 when they ran the output. But that would also mess up all the other tables. I don't know how they did it actually. No, it's probably a mistake. Well, anyways, don't mind me. Let me go back. Okay, 150. This is actually much nicer without the sidebar. I'm gonna keep it at that format. All right. Where did we start reading? Okay, maybe. Okay, the program itself consists of the definition of a single function named main. It no longer, it is, I think we did that. It is longer than the one that printed hello world, but not complicated. It introduces several new ideas, including comments, declarations, variables, arithmetic expressions, loops, and formatted output. The two lines, printf Fahrenheit Celsius table for the range, are comment, which in this case explains briefly what the program does. Any characters between the /* and */. No, this is also a / are ignored by the compiler. They may be used freely to make a program easier to understand. Comments may appear anywhere where a blank line, tab, or new line can. That's interesting. So on a new line where there can be blank, so what are they talking about? Like in between variable declarations? That's actually something I want to test out. So we just do GCP. Just commit that, but then I'm wondering, like, can I have a comment in between this? I can. Let's add one more here. So like, yes, it comes to the indentation. That's the idea. Is there still 1, 2, 3, 4? Yeah, let's do that. Because my formatter is not working. Why is that? Wait, my Clang format's not configured. But why? I'll debug that later, but if I run // it should auto format, so I'm not too worried. Yeah, that is a fucked up formatting, man. Why did it not format the... Oh, this does do the inline formatting. One sec. Bruh. I think I uninstalled LLVM and Clang format came with that. So now that I don't have LLVM, it doesn't know where to find it. Makes sense. Okay. Yeah, now it's formatted nice and clean. Yeah, but the problem is it formatted the comments as well, which is a bit dumb, but yeah, sure. Okay, all C variables, where is it? In program and that by the compiler may be used freely to make programs, sure. Blanks, tabs, or new line. In C, all variables must be declared before they are used. So not just at the top of the function, so just before being used. Usually at the beginning of the function, before any executable statements. A declaration announces the properties of variables. It consists of a name and a list of variables such as this. The type int means that the variables listings are integers by contrast with float, which means floating point, in a sense, numbers that may have a fractional part. The range of both int and float. Oh, sorry. I just read over that without actually explaining. So floats are basically decimal points. The range of both int and float depend on the machine you're using. So this is machine dependent. 16-bit integers, which is between -32,000 and +32,000, are common as are 32-bit ints. This is not the case anymore. All our ints are they 64 bits on modern machines? I'm assuming so. unless you explicitly like define how many bits you want, I think. So with the size t stuff, a float number is typically a 32-bit quantity with at least 6 significant digits and a magnitude generally between 10 to the power negative 38 and 10 to the power positive 38. So this is the part I don't really understand how this part works. I need to learn like binary to actually understand what's going on. C provides several other data types besides int and float, including character, short, long, double. So character is basically a single byte. Short is a short integer, long is a long integer. This is, I think, supposed to mean like shorts are 16-bit, longs are 32-bit. That was the idea, I'm assuming. But then what is int? Wait. So double is double precision floating point, so bigger than float. That's double. So if a float was like 32 bits, that would be 64, I'm assuming is the idea. Because a float is 32-bit, so double would be 64, maybe. The size of these objects is also machine dependent. There are also array structures and unions of these basic types, pointers to them, and functions that return them, all of which we will meet in due course. Sure. Computation in the temperature conversion program begins with the assignment statements. So these, which set the variables to their initial values. Individual statements are terminated by semicolons. Each line of the table is computed the same way, so we use a loop that repeats once per output line. This is the purpose of the while loop. So that's where we start with the while, the keyword, and then we loop until Fahrenheit is less than or equal to the upper limit. The while loop operates as follows. The condition in parentheses is tested. If it is true, which is Fahrenheit is less than or equal to upper, the body of the loop, the 3 statements enclosed in braces, is executed. Then the condition is retested, and if true, the body is executed again. When the test becomes false, which is Fahrenheit exceeds upper, the loop ends, and execution continues at the statement that follows the loop. So which is basically the scope bounding. So things within the curly brace stop running, and we continue on to the next line. The body of a while loop can be one or more statements enclosed in braces, as in the temperature converter, or a single statement without braces. So if I just do one single statement with a semicolon like in line, we can make this look pretty. So let's try that. We'll just do, they did this example, so we'll do an int I. Let's just make a commit first. And it should be it. If we now do, that's a thing, that's nice. No, that's not a thing. I thought like I was able to like delete within. How do we do? So SI, no, it doesn't work. SI star, no. Yeah. Wait, why can't I still format this? My editor formatting isn't working. This is weird. We'll check that later. Oh, what I actually wanted to test was the while loop. So we do while. We start with an I because we need to declare this, and then I less than j, also j. Let's say 9. I is less than j. Oh, it's supposed to be a one-line thing, so I equals to 2 times I equals to 2 times I, sure. So I can have it one line, or have it like this. And the thing is, if I format, and then into an infinite loop, why is that? While I is less than j, mixing declarations and code, that is a warning. So I'll just go the tippity top. While I is less than j, you're supposed to increment j. No, we're supposed to increment I. That is interesting. Times, yeah, we're doubling it then. What's the problem? The program is not exiting. Am I missing something? What? No, this can't be right? If I just move this code like up here, what happens? 4 warning generated. What am I doing wrong? Huh? Bro, I'm so confused right now. If I is 0, j is 9, while I is less than j, we increase I. I'm dumb. We're multiplying by 0. And there you go. Bruh. Because I usually start I at 0, so I thought I'd just start at 0 again. That makes sense. In either case, we will always indent the statements controlled by the while by one tab stop, which we have shown as 4 spaces. So that is also 4 spaces for us in Microsoft style. So you can see that at a glance, which statements are inside the loop. The indentation emphasizes the logical structure of the program, although C compilers do not care about how a program looks. Proper indentation and spacing are critical in making programs easy for people to read, which is not relevant in these days of AI and stuff, but we recommend writing only one statement per line and using blank lines around operators to clarify grouping. The position of braces is less important, although people hold passionate beliefs. I do too. I like tabs, actually, which is 4 spaces. We have chosen one of the several popular styles. Pick a style that suits you and then use it consistently. So I went with the Microsoft style, even though they don't use tabs, but I can live with that. How long is this? Bro, I'll just read up to this part. So most of the work gets done in the body of the loop. The Celsius temperature is computed and assigned to the variable Celsius by the statement Celsius equals to 5 times Fahrenheit minus 32 divided by 9. The reason for multiplying by 5 and dividing by 9 instead of just multiplying 5 by 9 is that in C, as many other languages, integer division truncates, which is basically they drop the fractional part. So any fractional part that is discarded since, they explain it in the next slide. Since 5 and 9 are integers, 5 by 9 would truncate to 0, and so all Celsius temperatures would be reported at 0. So if we were to try that for ourselves, let's commit that as well. Then after that, we do this, which is Fahrenheit is lower upper. Yeah, instead of this formula, which is the correct one, we do 5 times 9, so 5 by 9 times Fahrenheit. I think the parenthesis needs to stay, otherwise it would multiply the Fahrenheit first. And if we run that, we do get an extra warning, which is, comments are not allowed in this language. What? Oh, I think they mean this format, so yeah, this is allowed. So everything just turns to 0. That should be it. This example also shows a bit more of how printf works. Printf is a general purpose output formatting functions, which we will describe in detail in chapter 7. Its first argument is a string of characters which to be printed, with each percentage indicating where one of the other second, third, or fourth arguments is to be substituted. I'm actually curious on how C handles n number of arguments and in what form it is to be printed. For instance, %d specifies an integer argument, so the statement printf percentage d backslash t %d backslash n, and then Fahrenheit and Celsius as the second and third argument will basically substitute the first and second %d format specifiers, because the values of the two integers Fahrenheit and Celsius to be printed with the tab between them, and then a new line. Each percentage construction in the first argument of printf is paired with the corresponding second argument, third argument, etc. They must match up properly by the number and type, so you cannot mix and match like percentage d with a f. You can, those will be implicitly like converted, I think, but yeah, you will get wrong answers. By the way, printf is not part of the C language. There is no input or output defined in C itself. Printf is just a useful function from the standard library. Yeah, because languages cannot input or output, which does make sense. Printf is just a useful function from the standard library of functions that are normally accessible to C programs. The behavior of printf is defined by the ANSI standard, however, so its properties should be the same with any compiler and library that conforms to the standard. In other words, to concentrate on C itself, we don't talk much about the input and output system until chapter 7. In particular, we will defer formatted input until then. If you have to input numbers, read the discussion of the function scanf in section 7.4, which is scanf is like printf except that it reads input instead of writing output. So we will go until chapter 7 before getting inputs. That is not chapter 7. Really? Chapter 7 is when we do inputs? That is crazy. There are a couple of problems with the temperature conversion program. The simpler one is that output isn't very pretty because the numbers are not right justified. That is true, but it doesn't bother me actually. That's easy to fix. If we augment each percentage d in the printf statement with a width, the number printed will be right justified in the fields. For instance, we might say 3d and 6d followed by a space and then backslash n. So let's try that. So you go back to our okay, so we can just do 3D. We remove the tab and then we do 6D. So this is basically generating that artificial space in between. And that's how we get a pretty looking table. Yeah, that is actually quite nicer than the previous output. Where is it? Yeah, I like this. Okay. So we do that to print the first number of each line in a field 3 digits wide and the second in a field 6 digits wide, like this. Okay. The more serious problem is that because we have used integer arithmetic, the Celsius temperatures are not very accurate. That is true. For instance, 0 degree Fahrenheit is actually about negative 17.8 degrees Celsius, not 17. That is actually quite a big difference, by the way. To get more accurate answers, we should use floating point arithmetic instead of integer. This requires some change in the program. Here's the second version. So we'll basically be using floats, I think. Yeah, so we do floats. Nothing else really changes on the structure of the formula. And that's the wrong part. I highlighted this part, and the format specifiers to be now f with decimal precisions. So if we do no longer ints, I think, yeah, these are all floats, not like the floats. We do float, and then we change the formula to be, oh, hi there. Oh, that's a bot, never mind. So 5 by 9 and then times this. So we can do minus that and then do percent. Yeah, it's already like complaining. Result of an integer division will be in floating point. Why is that? 5 by 9 or 5.9. So 5.0, 9.0, and then we use parentheses. Yeah. What else? Faren minus 32.0. Implicit conversion. There shouldn't be any implicit conversions. Why is there implicit? Fahrenheit itself is a 0. Implicit conversion loses floating point double to float, which is a double. So by default C does doubles, I think. So if I were to do F, that would fix it. Yeah, that does fix it. So we're not going to do that, but we'll keep it in mind. And as for the format specifiers, it becomes 3.0f, I think. Yeah, 3.0f and 6.1d. 6.1d? No, it should be also f. Yeah, f. Let's do 2 digits because we're fancy like that. Oops. And now we have a fancy looking table. It's not as spacious as before though, so let's just stick to 1, I think. What else? Yeah, this is much the same as before. Let's just make a commit first. So this is much the same as before, except that Fahrenheit and Celsius are described to be float, and this formula for conversion is written in a more natural way. We were unable to use 5/9 in the previous version because the integer division would truncate it to 0. A decimal point in a constant indicates that it is a floating value. However, so 5.0 by 9.0 is not truncated because it is the ratio of two floating point numbers. If an arithmetic operator has integer operands, an integer operation is performed. If an arithmetic operator has one floating point operand, the one integer operand, however, the integer will be converted into floating point before the operation is done. So that's the implicit conversion bit. If we had written Fahrenheit minus 32, the 32 would be automatically converted to floating point. Nevertheless, writing floating point constants with explicit decimal points, even when they have integral values, emphasizes the floating point nature of for human readers. The detailed rules for when integers are converted to floating points are in chapter 2 for now. Notice that the assignment Fahrenheit equal lowers and the test while Fahrenheit is lower than or equal to upper also work in the natural way. The int is converted to float before the operation is done. So we could technically, to be like fully compliant, this is already like done, but you should be able to just do like something like this that converts it, but we're not going to do that. That is done implicitly for us. Okay. The printf conversion specification, so percentage 3.0f says that a floating point number, here Fahrenheit, is to be printed at least 3 characters wide with no decimal point and no fraction digits. Yeah, so 0f. Percentage 6.1f describes another number Celsius that is to be printed at least 6 characters wide with 1 digit after the decimal point. The output looks like this. So even if it didn't have a decimal, like, what do you call it, fractional value, it would still get printed like as decimal 0. Okay. So that the output looks like this, and width and precision may be omitted from a specification. So just percentage 6 says that the number is to be printed at least 6 characters wide. Percentage 2, just dot point 2 specifies 2 characters after the decimal, but the width is not constrained. And percent f merely says to print the number as floating point. Now I'm actually curious what would happen if I do so percent f. So let's just do like variations of this. We'll do a percent f only. Let's see how it turns out. Should I introduce the tab again here? So that's how it looks. And yeah, this is what I was talking about. So how far would it go? So for even 0 values, it just goes 6 digits. Is that the idea? Yeah, percentage, like percent f, I never specified anything. I'm guessing that's the default. And then if I do dot 2, that would mean the first half isn't bound. But if I do a 6f, yeah, how does that sound? So we'll do 3f and then 6f. Yeah, but it's still gonna like overshoot the 6 part though, because this itself is 6 digits and it's gonna take more. So it just means at least prints as floating point at least. Yeah, so that's the key part here. So it will print at least that much, but it can take more spaces. But for the decimal ones, it will always still do at least, I'm assuming. So no, it won't do at least, it will do at max. So after the decimal point, it's at max, but before that it is at least. Okay, that is interesting. No, it's not even at max, it will strictly do 2 characters. So I think we should add a note. So cl.2f. No, I did it the wrong way. So we do digit dot is and spaces. Uses 0. Actually, I need to check this. Doesn't print. Oh, just uses spaces. What? Okay, that shouldn't be all I need. So printf format specifiers, that's what it is. So now to the exercise. Modify the temperature conversion program to print a heading above the table. Okay, that's easy. So we get rid of the stupid comments, and then we do 3f and then a 6. Wait, is that how we were doing it? 3.0 and 6.1. 3.0, 6.1 f. Okay. So and as for the heading, it just goes, we do it here, I think. Will it work? Fahrenheit to Celsius. Oh, we need a new line and maybe a bit more spacing. I have an idea. One sec. So we'll do Fahrenheit and then make it 4. We'll do a new line, of course, and then 1, 2, 3, 4, 5, 6, 7. We do 7.1, which is 5. Actually, we need to do it like this, and for the tab we need 1, 2, 3, 4. So that's already like taken care of. So if we now run this, it doesn't do use spaces. That is something I got wrong. It will simply not use that space. Okay, now how do we do that? I don't think I can do this. Like the problem is I'm trying to make it use at least this many characters. So, oh, I need to change this. So 1, 2, 3, 4, 5. 6. How does this work actually? I don't think I understand that, but yeah. So if I want like 7, I think spaces, because that's the width of the Celsius word. 1, 2, 3, 4, 5, 6, 7. Yeah. Yeah, that's what I want. So it will use within the 7 spaces 1 decimal point and 1 digit after, and then use the rest remaining 5 for the alignment of the other stuff. Cool. And the wait, I scrolled too far. Yeah, so write a program to print the corresponding Celsius to Fahrenheit table. Also, we need to go in reverse. Oh, now this is the fun bit. So we do Fahrenheit is lower, so instead it becomes Celsius is the lower and So we'll go from 0 to, I think, 30 in increments of 2. Yeah, so 0 degrees Celsius to 100 degree. Let's just keep the bounds the same, I think, but it will get ridiculous like Fahrenheit numbers. No, let's just change that. So we go from 0 degrees to 40, I think. No? 38 sounds good. In increments of 2, 4. Okay, so Celsius is lower, and this becomes Celsius to Fahrenheit. Printf now basically reverses, so it becomes 7. Oh, it doesn't need any large number, that will always be 2.0f. So that's our flat increase in Celsius values. But then for Fahrenheit, 6.2, 7.2. It'll take the, yeah, this table doesn't hold up anymore. We need more spaces for Fahrenheit, so we'll do 1, 2, 3, 4. Like that maybe. So let's give it some more space. Yeah, that should be enough for the Fahrenheit. So 1, 2, 3, 4, 5, 6. So I'll give it 6 digits. If it's not bounded within that, well, I don't know. So we need, Celsius is still going to be 7 because we want them to be right justified, but then the gap, we need to change that 1, 2, 3. Oh, let's just make it 4. 1, 2, 3, 4, 5, 6, 7, 8, or just 8 spaces, so double tab should be fine. All right, that's good actually. And then the problem becomes this part, so you cannot use double tabs. You just have to use this. And as for the formula, what does it become? Fahrenheit to Celsius formula, let's just look it up. We do temperature times 9/5 plus 32. So Celsius. And then this part basically goes. And we change the order, so yeah, that's our program. I got myself into a loop. Celsius is lower than upper. So not Celsius, Fahrenheit. Okay. I completely botched it up, didn't I? So we want, Celsius is working fine. Then we want a number of spaces. Yeah, tabs aren't reliable, I think. So we'll just go 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. We can't do 8 spaces. So we need to do 4, 5, 6. So we'll do 2 here. Am I missing something? I'm missing something. Let's just do it the normal way, man. Okay, so we need to just increase the Fahrenheit's distance. Too much. How about a single tab? Too little. I don't understand tabs. Oh, this lines up now. So the problem is Fahrenheit calculations are definitely wrong. Fahrenheit is, I think Celsius to Fahrenheit. Yeah, that's the formula. So you times Celsius times, not divide, times 9 by 5. 9 by 5. It's reversed. Alright, now it looks good. So 0 degrees is negative. Then 36 is... that is still wrong. 36 degrees should be like, what? 70, 80, I think? Celsius times 5 by 9. Do I need another set of parentheses like that, maybe? No, it doesn't work. Oh, can we test it? So what is 38? 38 is 100. Yeah, it's supposed to be 100.4. What are you doing wrong? We're printing Celsius and then Fahrenheit. And every time Celsius increases, we recalculate 32.0. Plus, it's not minus. Okay. I need to learn how to read, man. Okay, now this. So since we've made it like 40, we need to go like that. And we have ourselves a nice table. So 40 degrees is 104. That's fever. And that's how we go Fahrenheit. Sorry, Celsius to Fahrenheit table. Makes sense. And that should be it for now, because we have done the exercises up to 1 point. We've done the entirety of 1.2. I think that's a good stopping point. We've been at it for what, an hour and 11 minutes. Fine. Yeah, that's the one I've been listening to. We had one bot that joined us. Lovely. So if we were to browse the repository now, we have our commits. Okay. Yeah, nothing to look at over here. We just made how many? 14 contributions today. Yeah, that's all. I'll just use like the C matrix as a temporary thing and then stop the stream.